Right now, above our heads, something strange is unfolding, quietly, invisibly, yet powerful enough for the most advanced instruments on Earth to take notice. Most people going about their day have no idea anything is happening. They can't feel it. They can't see it. Yet deep within the magnetic shield that wraps around our planet, a subtle tremor has rippled through the system, catching the attention of scientists at NASA, ESA, and several research teams at Harvard. Not a doomsday event, not a reversal of Earth's poles, but something unusual enough that the timing alone has sparked curiosity across the scientific world. And the timing is where this story begins to feel almost poetic, because just days before this magnetic fluctuation appeared in the data, something rare passed through the outer boundary of Earth's orbital neighborhood. An interstellar object designated 3E Atlas briefly crossed our region of space. Only 3 such objects have ever been confirmed in human history: Oumuamua in 2017, Borisov in 2019, and now this one. They are the true outsiders of the cosmos, wanderers born under another star, traveling for who knows how long before slipping silently past our solar system. Most people never hear about them. Most barely notice. But every time one arrives, astronomers from around the world stop what they're doing, because each one is a message written in the language of the galaxy, carrying clues about worlds we've never seen. And this time, by coincidence or by cosmic rhythm, an interstellar traveler passed through just before Earth's magnetic field produced an unexpected ripple. No one is claiming the two events are connected. No evidence supports that. But the overlap was enough to send researchers back to their data, scanning frame by frame, measurement by measurement, to understand exactly what Earth reacted to. Before we go deeper, take a moment to hit the like button, subscribe, and let me know where in the world you're watching from. I love scrolling through the comments and seeing this global community come together, people from every corner of the planet united by curiosity, by wonder, by the desire to understand the mysteries above us. It's incredible to think that no matter where you stand, whether it's a sprawling city, a quiet village, a desert, a snowy mountain, or an island in the middle of the ocean, we all live beneath the same magnetic shield, the same invisible armor generated by the molten heart of our planet. That shield, Earth's magnetosphere, is one of the most important forces in your life, even if you never think about it. Without it, solar radiation would bombard our atmosphere, satellites would fail, GPS would collapse, our planet would be exposed to the constant stream of charged particles flowing from the sun. And yet, for billions of years, this magnetic field has held firm, bending and flexing, but always maintaining a protective boundary between Earth and the raw energy of space. Most of the time, the magnetic field is predictable. It drifts gently, it shifts slowly. It's almost like a great ancient creature breathing quietly in its sleep. Scientists track these movements with magnetometers placed across the globe, sensitive instruments capable of detecting the tiniest changes in Earth's electromagnetic heartbeat. And for years, the pattern had been consistent: a slow drift, a gentle wobble, a steady hum. Then, this week, something different happened. A cluster of monitoring stations, spread from Iceland to Antarctica, captured a synchronized deviation, not a massive surge, not a catastrophic spike, but a quick, clean, coordinated tremor that lasted only minutes. A sudden pull in a new direction, followed by a return to stability, as if the field had flinched. Researchers noticed it immediately because events like this usually have obvious causes: a solar flare, a burst of solar wind, a coronal mass ejection racing toward Earth. But when they checked the data from the sun, the readings were silent. No storms, no flares, no sudden bursts of energy. And that silence is what triggered the questions, because when Earth's magnetic field reacts, something usually pushes it. Yet this time there was no push anyone could identify, at least not from the usual suspects. So researchers began digging deeper, comparing timestamps, scanning satellite readings, looking for anything at all that could explain the anomaly. And that's when someone noticed the coincidence. Just days earlier, 3 IATLAS, the interstellar visitor, had passed the plane of Earth's orbit. It didn't come close enough to physically interact with our planet. It didn't emit radiation that would disrupt magnetic fields. From what scientists could observe, it behaved like a faint, loosely bound object, perhaps icy, perhaps dusty, perhaps something more complex but still natural. Yet the timing was interesting. Imagine standing beside a calm lake. The water is still, then far out in the distance, something drops into the water, a stone, a branch, or perhaps nothing you can see. But moments later, gentle ripples reach your feet. You don't know the cause. You only see the effect. That's how this magnetic event feels to many researchers. Not a threat, not a crisis, but a ripple worth paying attention to. When ESA's swarm satellites processed the data, the visualization they created showed a faint spiral-like oscillation, something like a brief twist in the magnetosphere, not dramatic but unusual. Some scientists describe it as the magnetosphere ringing for a moment, the same way a bell rings when lightly tapped. It's a perfectly natural phenomenon, but the clarity of the motion made it stand out. NASA's reports describe the incident as a temporary magnetic anomaly with an uncertain cause, nothing alarming, nothing dangerous, nothing that should spark fear. But the fact that it happened at all is intriguing, especially in a world where we're still learning how Earth responds to the environment around it. Not just to the sun, but to cosmic influences we barely understand. For those who imagine something exotic or science fiction-like, the truth is simpler and far more beautiful. The universe is dynamic. Magnetic fields are constantly forming, colliding, resonating, and dissolving across the cosmos. Our own planet is part of that dance, and every once in a while something subtle shifts, reminding us that even forces we take for granted, like the magnetic field, are alive with motion. But the real question is, why do these tiny anomalies captivate us so deeply? Why do they spark fascination, curiosity, even a hint of unease? Maybe it's because they remind us that we still know so little. We like to think of Earth as a stable place, predictable, constant, anchored in unchanging rules. Yet the universe doesn't operate that way. It flows, it whispers, it nudges, and sometimes those nudges show up in our data in ways we don't expect. Think back to the moment you first encountered something invisible but real. The hum of electricity behind your walls, the subtle vibration of a train arriving, the quiet static on a radio when a signal drifts in. When I was a kid, I built my first radio out of scrap metal, copper wire, and a few old components I barely understood. I remember turning the dial and hearing faint voices from miles away, carried by waves I couldn't see. It felt like magic, but it wasn't magic. It was physics. Layers and layers of physics stacked so precisely that whole worlds of sound could travel through the air unnoticed until the right circuit captured them. Earth's magnetic field is like that radio, constantly tuned, constantly listening, constantly interacting with forces across the solar system and beyond, and sometimes, just sometimes, a faint vibration passes through that reminds us we are part of a much larger story. Scientists don't believe 3IATLAS caused the magnetic shift. There's no evidence for that. But the coincidence has sparked discussion about how sensitive our magnetosphere really is. Could a passing interstellar object trigger subtle changes simply by moving through the solar wind? Could its interaction with surrounding plasma create tiny ripples that reach Earth? These aren't claims, they're questions, and questions are how science moves forward. What really fascinates researchers is how precisely the magnetic fluctuation appeared across multiple monitoring stations. In Alaska, Greenland, Northern Europe, and parts of the Southern Hemisphere, instruments recorded nearly the same pattern at nearly the same moment. That level of synchronization suggests a global response, not a localized disturbance. Imagine Earth as a giant tuning fork, humming with magnetic energy. When something nudges one part of it, even something subtle, the vibration spreads, the whole system resonates. And in the recordings from this week, that resonance can be seen clearly, as if the entire planet participated in the same brief coordinated motion. It wasn't strong enough for humans to feel. Birds didn't suddenly change direction. Compasses didn't swing wildly, but the instruments felt it. The same way a seismograph detects an earthquake too small for humans to notice, it's a reminder that our world is alive with forces far more delicate than our senses can perceive. And what makes this moment even more interesting is that the sun was unusually quiet at the time. Typically, when Earth's magnetosphere shifts abruptly, the sun is involved, a burst of charged particles, a solar storm, a high-speed stream from a coronal hole. But this time, nothing. The solar wind was calm. The sun's surface was quiet. It was, in a way, the perfect moment for a subtle anomaly to stand out. Scientists often talk about magnetic breathing, the natural expansion and contraction of Earth's magnetic field as it interacts with the solar wind. But what happened this week didn't look like the usual inhale and exhale. It was sharper, cleaner, more synchronized. In the coming months, researchers will comb through the data. They'll compare notes from satellites, ground stations, and deep space observatories. They'll ask new questions about how interstellar visitors interact with the heliosphere, the vast bubble carved out by our sun. And maybe they'll discover something new, or maybe they'll confirm that this was just another natural part of Earth's magnetic rhythm, rare but not unprecedented. But for now, we're left with a fascinating moment where Earth, quietly and without fanfare, seemed to react to something in its environment, a tiny ripple in a vast sea of invisible forces, a reminder that even in an age of satellites and supercomputers, the universe still surprises us. As the investigation continued, conversations among researchers shifted from the immediate anomaly to the broader implications. Not dramatic implications, not dangerous ones, but the kind that spark curiosity about how interconnected our cosmic environment truly is. Because if there is one thing this moment highlights, it's that Earth does not exist in isolation. Our planet sits inside a constantly shifting ocean of magnetic fields, solar winds, charged particles, and gravitational tides. Even when everything seems calm on the surface, space is never truly quiet. What makes this event so compelling is not that something impossible happened, but that something subtle happened at the perfect moment to catch our attention, a delicate magnetic tremor, a silent interstellar visitor. Two events that in any other week might have gone unnoticed. Yet here they are, woven together by timing alone, reminding us how vast and unpredictable the universe can be. Meanwhile, astronomers continue tracking 3IATLAS as it moves farther away from Earth. As it fades into the outer reaches of the solar system, its brightness has already dropped beyond the limits of most ground-based telescopes. Soon, it will return to the darkness it came from, drifting endlessly through interstellar space until another star's gravity catches it, or until it vanishes into the shadows between worlds. And yet, for a brief moment, it passed near us, too distant to touch, too faint to feel, but close enough to leave us wondering what stories it carries from the stars it once orbited. It brings to mind something scientists often say: every interstellar object is a messenger, not in a mystical sense, but in a scientific one. These objects contain materials older than our solar system, shaped by environments we may never directly observe. They hold clues about how other planetary systems form, how they evolve, how they die. Simply detecting one is like finding a message in a bottle floating across the cosmic ocean. Of course, that doesn't mean they cause events on Earth. There's no evidence for that. But their arrival reminds us that the galaxy is alive with motion and that our solar system is constantly interacting with forces beyond the sun's influence. Even the space between stars is filled with magnetic fields, dust, plasma currents, and gravitational influences we're still learning to measure. This perspective is something Michio Kaku often talks about, the idea that Earth is part of a much larger tapestry of cosmic dynamics. Our magnetic field doesn't just protect us, it connects us to a broader electromagnetic environment. It resonates with the solar wind. It shifts with changes in the heliosphere. It responds to fluctuations that ripple across billions of miles. And those responses, while usually subtle, sometimes produce moments like the one we observed, moments that challenge us to pay closer attention. As more data comes in, one of the early theories gaining attention involves what scientists call magnetospheric resonance. It's a natural phenomenon where Earth's magnetic field can briefly oscillate when disturbed by changes in surrounding plasma density. Usually, these oscillations are triggered by solar activity, but smaller, quieter triggers can also create ripples that propagate across the magnetosphere. In other words, the magnetic field can ring even when the sun is calm, responding to shifts in the plasma environment that are normally too subtle to notice. What stands out this time is how clean the signal was, like a single note played on a massive instrument. That clarity is what fascinates researchers, not because it suggests something supernatural or defies understanding, but because it offers a rare opportunity to study how exquisitely sensitive Earth's magnetic system can be. Every anomaly, even the small ones, teaches us something. Every unexpected pattern reveals another layer of the magnetic processes that shape our world. And perhaps the most humbling realization is that these processes are always happening. They don't begin when we notice them, and they don't end when the data scrolls off the screen. Earth's magnetic shield is constantly shifting, adapting, stretching, and flexing with the energy that flows around it. We just happened to catch one of those moments at the exact time an interstellar visitor passed by, giving us a story that feels symbolic even if the connection is only in our imagination. For some people, that coincidence is enough to spark a sense of wonder, not fear, wonder. Because sometimes the universe aligns in ways that feel almost intentional, even if we know they're not. A rare object enters our region of space. A delicate tremor ripples across Earth's magnetic field. Two completely natural events occurring in close proximity, but together they remind us that reality is far more layered, far more dynamic, far more surprising than the version we experience day to day. And maybe that's why moments like this resonate so deeply. They give us permission to look up from our routines, our deadlines, our small daily concerns, and remember that we live on a planet suspended in a vast cosmic sea, a world with a living magnetic heartbeat, a world protected by forces we can't see but depend on every second, a world surrounded by mysteries that challenge us to keep discovering. In the days following the anomaly, teams across multiple agencies began comparing their findings. The United States, Europe, and several independent observatories exchanged recordings to build a full picture of what happened. In conversations that leaked into academic circles, scientists described the event as unusual, but in a scientifically interesting way. Not alarming, not unprecedented, but definitely worthy of close study. Some of the most intriguing data came from a research station in the Arctic Circle, which recorded a faint, low-frequency vibration during the event. Not a sound, there's no sound in space, but a fluctuation in the magnetic environment that instruments translated into an audible frequency. It lasted only moments. It wasn't unique, but it aligned perfectly with the global tremor recorded elsewhere. To researchers, it was simply another piece of the puzzle, a clue about how the magnetic field distributes energy across its structure. One of the researchers involved described the experience in a way that stuck with me. He said, "We're used to thinking of the magnetic field as a shield, but it's more like an ecosystem. It moves, it breathes, it reacts." And he's right. We tend to picture magnetic fields as rigid, static lines drawn on diagrams. But in reality, they are fluid, flexible, constantly reshaping themselves in response to every particle and wave that passes through, which leads to an even deeper question. How much about Earth's magnetic behavior do we truly understand? We study solar storms, we track pole drift, we monitor the shielding around the planet, but there are subtler dynamics at play: waves, eddies, resonances, interactions with cosmic plasma that remain on the edge of our scientific understanding. These delicate behaviors might be happening all the time, simply too soft for us to detect except under the right conditions. Events like this offer a rare chance to refine our models, improve our satellites, and deepen our understanding of how the magnetosphere responds to its environment. And the more we learn, the better prepared we'll be for moments when the sun does unleash something powerful or when the magnetic field behaves in unexpected ways. Study builds resilience. Knowledge becomes protection. As 3I Atlas retreats into the outer solar system, most telescopes can barely pick up its dim signature now. In a few months, it will be completely invisible to us, a traveler passing into darkness once again, carrying secrets from a star system we may never know. Its brief appearance here will be filed away in astronomical records, another data point in humanity's long attempt to map the galaxy's wanderers. But the magnetic anomaly it happened to coincide with will continue to ripple through scientific discussions for months, not as a warning, not as a crisis, but as an intriguing reminder of how interconnected everything truly is. A reminder that our planet is not an isolated island in space, but part of a network of forces stretching across light years. And maybe that's the part that resonates the most. Because whether or not 3I Atlas had anything to do with the magnetic tremor, the two events together form a powerful symbol. A symbol of curiosity, a symbol of cosmic scale, a symbol of how the universe can whisper to us in subtle ways, inviting us to look deeper, ask questions, and take nothing for granted. In moments like this, you can't help but feel a sense of humility, a sense that our planet is just one participant in a vast and ancient conversation, a conversation expressed not in words or light, but in fields, forces, and the invisible language of physics. Sometimes we catch a fragment of that language, a ripple in the magnetosphere, the passage of an interstellar visitor, and for a moment we feel connected to something far larger than ourselves. So as the data continues to flow in and as scientists work to understand every nuance of what happened, we're left with a simple, profound truth. The universe is always speaking not loudly, not dramatically, but through the gentle hum of magnetic forces, the quiet drift of interstellar dust, the subtle motion of space itself. The real question is whether we're willing to listen. Now tell me, do you think the timing between the magnetic tremor and the passage of 3I Atlas was pure coincidence? Or could there be a deeper natural connection we're just beginning to understand? Share your thoughts below, and if you haven't already, make sure to like, subscribe, and share this video with someone who still looks at the night sky with wonder. Because the more we learn, the more we realize that every shift, every ripple, every cosmic visitor is part of a story still being written, one that stretches far beyond Earth, and one that will continue long after our time here is gone. In the coming months, researchers will comb through the data. They'll compare notes from satellites, ground stations, and deep space observatories. They'll ask new questions about how interstellar visitors interact with the heliosphere, the vast bubble carved out by our sun. And maybe they'll discover something new, or maybe they'll confirm that this was just another natural part of Earth's magnetic rhythm, rare but not unprecedented. But for now, we're left with a fascinating moment where Earth, quietly and without fanfare, seemed to react to something in its environment, a tiny ripple in a vast sea of invisible forces, a reminder that even in an age of satellites and supercomputers, the universe still surprises us.